Yeah, good afternoon to everyone. Good afternoon. Once again, my name is Mr. Hunpe, JS, and I will be taking you physics. So every Thursday, 4 to 5 p.m. So, but before I start today's lesson, so I will have to seek for apology from every one of you concerning the failure of the last class. So it was due to one reason or the other. So that was the reason why the class couldn't hold, so as scheduled. So the barrister tried, the whole fault came from me, but I did not intentionally not to attend to the class. So if you could observe, I started the class, but one thing or the other came up. So, but I'm so sorry for any inconveniences this would have caused every one of you. So without wasting much of our time, so let's begin with today's activity. Now, this afternoon, we want to start with physics, and there's no way I can start, according to the scheme of work, we're supposed to start with the concept of matter, but there's no way I can start with the concept of matter without letting you know what physics is all about, because the main thing that we need to understand is physics. So many students see physics as if it is a problem subject or a difficult subject, but it's not like that. So the key fact of physics is that you should understand the fundamental principle of it. And if you understand the fundamental principle of it, so you won't have problem. So concerning physics. So firstly, let's start with the definition of physics. So when we talk about physics, so what are we talking about? So what is physics? So physics, as we all know, is a branch of science that deals with the nature and property of matter and energy. So once again, physics is a branch of science that deals with the property and the nature of matter and energy. Meaning that everything concerning physics is all about matter and energy. So these two concepts is what you need to first put at the upper half of yourself. So I know that whatever we are going to be dealing with under physics is all about matter and what? And energy. So, but under this matter and energy, some key subjects that we will be looking into, and they include magnets. They include magnets, light, heat. So magnets, light, heat, and some other radiation, and some other radiations like electricity. What again? Sound. So sound, magnetism, and properties of atoms, and properties of atoms. So whatever concerning physics, so these are all what we'll be looking into. So it's a branch of science that deals with the nature and properties of matter and energy. So with that, I think you have understand what the definition of physics is all about. Again, physics is a branch of science that deals with the what? With the nature and properties of matter and energy. So, and under it, the key subject or key topic that physics cover are the mechanics, the light, heat, and some other radiation like electricity, sound, so magnetism, and the structure of atoms. So from there now we can begin with the concept of matter. Do not forget, we said physics deals with the nature and property of matter and energy. So we can start with the matter now, the concept of matter. Let's start with the concept of matter. So we all have already know what matter is, but that's why you know what matter is. So my own objective here is to do what? To put more light to what matter is for you. So to put more light to matter, so you can understand what matter is and its relation to the subject so that we are dealing with, which is what? The physics. So the relation of matter and to the what? To the physics. So matter is a substance that has inertia and occupied physical space. So matter is anything that has inertia and what? And occupies physical space. So without matter is anything that has inertia and occupy physical space. So it is a KGT definition when we just say matter is anything that has weight and occupying a space. But normally, so it's anything that has inertia. And we talk about inertia means that something that cannot change. You understand? So something that cannot change or changeable something, or something that has no impact. So that is so what matter is. So matter is anything that has inertia and occupy physical space. And we are talking about anything that has inertia and occupy physical space. So we are dealing with what? Matter. So under this, it consists of various types of particles, which with type of particle, each with mass and sizes. So matter, the property of matter, the properties or features of matter are mass and sizes. This means that every matter must have what? Mass and what? And sizes. So the most material particle example of matter. Okay, before I explain the board, so let me quickly do analysis of what we just explained now. So what I just explained now is that we are dealing with the concept of matter. We just started with the concept of matter. And they said that matter is anything that has inertia and occupies physical space. That is something that is unchangeable. So, and occupy the space. So that is what matter is. So, and when we are talking about anything that has inertia and occupies space, so they must have a mass and also have sizes. They must have mass and also have sizes. And that's what I just tried to explain. Now, besides the most material particle, so examples of matter are the most material particle example of matter that we will most talk about this afternoon. So the most material particle of matter that we must talk about this afternoon are one, so the electron to the proton and the neutron. Remember that all these three groups together form what? Atoms. So when electron, proton, and neutron join together, they form what? They form atoms. So that is the different, the most material thing that we will talk about under the matter. So the electron, the proton, and the neutron together form the what? The atoms. And the combination of atoms, if electron, proton, and neutron join together form atoms, and we now have groups of atoms. And we now have group of atoms. So what group of atoms we form is what we refer to as what? The molecules. So we refer to as molecules. I'm not trying to rush. So the goal of this lesson is everyone should understand. And maybe in one way or the other, at the end of the lesson, if anybody have any questions, you can drop it at my inbox. So the concept, the most material thing that we talk about, I said is they are the electron, the proton, and the neutron under the matter. And the electron, the proton, and the neutron all together forms what? Atoms. And a group of atoms so form molecules. I hope you all are following me. So, the group of atoms form molecules. Now, when the combination of molecules comes together, they form what we refer to as compound. So let's just take it from the simplest to the complex. On that matter, we will be talking much about the electron, proton, and neutron. And all these three things together form what we refer to as what? Atoms. And a group of atoms form molecules. A group of molecules form compound. A group of molecules form compound. I want you to understand that. To control some kind of distraction in the class. So now a group of electron, proton, neutron form atoms, and a group of atoms form molecules. A group of molecules form compounds. I hope you are understanding. So form compounds. So that is the most material things that we will be discussing under the concept of matter. So let's now talk about the state of matter. I hope you have gotten what I just said. The state of matter. Every one of us know that we have three states. Everyone of us know that we have three states of matter. You know that we have three states of matter, and these are one solid, so liquid, so liquid, like water. So example of solid material, they include like the chalk, the table, what again, book, so etc. So those are the example of solid state of matter. So we talk about the liquid state of matter. We can talk about the water. Another liquid substance. We can say liquor. What again? We can talk about your PMS, your fuel, your PMS petrol. So they are examples of liquid state of matter. We talk about gas state of matter now. So we can talk about hydrogen. We can even talk about oxygen. I talk about oxygen. Now, that is brief about the state of matter. So I think I want to move into it. So I want you to get what is on the chalkboard. So we said we have three states of matter. We have the solid state of matter, the liquid state of matter, and the gas state of matter. So we've tried to point to the example of the solid state of matter, which is example your chalk, your table, book, and other things that you think they are solid material. Liquid, water, so liquor, petrol, and every other thing that you think that they are liquid. So gas, hydrogen, oxygen, and others. So they are the examples of the state of matter. So that is here. Now, let me put your attention to this. So, different matter, in this state, different matter can be what? Can be combined to form another substance. Different matter can combine to form another substance that will give result to another form of matter that is different from the original form of matter. I hope you're trying to understand me. So, different matter can be joined together. I'm so sorry for the interruption. So we are in the school. I'm trying to stop the distraction so that is going on. So I want you to enjoy the class. Now, what I was trying to explain is this. So I said that so different matter can combine. So to do what? To form another substance. You can combine different matter together to form another substance that is different from the original matter that is combined. For instance, when you add two gas, for example now, for instance, so let's just put this is hydrogen. If you put hydrogen, remember that hydrogen is a gas state of matter. And if you add hydrogen and oxygen, together, so you are going to get another state of matter because hydrogen and oxygen will give rise to what? Water. I hope you are following too. So hydrogen and oxygen will give water. Do not forget that initially, so it is two gas state of matter that are joined together. Now they now give rise to another state of matter, which is what? Liquid state of matter. Which is the liquid state of matter. So hydrogen plus oxygen give rise to water. So that is what I'm trying to explain, that different matter can combine together to form another form of substance that is different from the original state of the matter that are joined together. So now the process of changing this matter to another form of substances is what we refer to as chemical reaction. It's what we refer to as chemical reaction. The process of joining the hydrogen and oxygen together to give rise to another state of matter is what we refer to as the chemical reaction. So it refers to chemical reaction. So chemical reaction involve the what? The interaction between the electrons of atoms. So it involves the reaction or interaction between the electron of the atom, but it does not do what? It does not affect the nuclei of the atom. I'll explain so that you can get the concept of what I'm explaining. Because today's class, we are not moving into any form of calculation until we move to the second topic, which is the fundamental and the derivative units. There, we start proving the formula. You get to know the secret behind the pieces. And if you understand that, you won't have a problem with anything concerning physics. So I can't rush it. What we are doing today is an introduction to physics and the matter. So now we've discussed the state of matter. So we talked about the solid state, the liquid state, and the gaseous state of matter. So and we've talked about the chemical reactions of matter, where two matter can join together to form another form of matter. So which refers to as what? Chemical reaction. So now let's move into the kinetic theory of matter. Let's move to the kinetic theory of matter. Let's move to the kinetic theory of matter. If you have any question, do not hesitate to drop it on my inbox. So the organizer or the director of the Jason, so we communicate my WhatsApp number so with you guys, and you are free to ask me any question at any moment, and we'll be available to supply any form, supply answer to any forms. Kinetic theory of matter.
Joshua. Hello.
What are the kinetic theory state about the matter? So we can start with the first. Remember that whatever we be discussing under this kinetic theory of matter, so you will be using them, we'll be applying them under any forms of calculation that will be coming up in the physics. So we'll be applying them. That is why whatever we discuss, you should not just memorize, or you should do what? You should understand the concept of it. So first, kinetic theory of matter states that so all matters consist of many or small particles which are constantly moving or in continual state of motion. So all matters, the first kinetic theory of matter states that all matters consist of many or small particles, so which are constantly moving or in continuous state of motion. So all matter consists of many or small particles. It may be small particles, it may be small or many particles, but they are constantly or in continuous state of motion. Either they are constantly moving or they are in continuous state of motion. So whenever continuous state, that's when we talk about the uniform acceleration. When the car travels, so when the car travels at the distance, God has said that the car will maintain a uniform acceleration. Whenever I'm uniform acceleration, that is, the car did not increase or decrease the speed. The car maintained a constant speed. Maintaining a constant speed is what refers to the uniform acceleration. Do not worry, do not panic. So we will move it to that gradually. So, but the text says that all matter consists of many or small particles which are constantly moving or in continuous state of motion. So, but the degree by which so the particle moves is determined so by the size or the energy of the what? Of the particle. Hope we are trying to understand me. We have said that the first kinetic theory of matter states that so all matter consists of small or many particles which are constantly moving or in continuous state of motion. But by the degree by which the particle moves is determined so by the energy or the size of what? Of the particle or the relationship of the particle to another matter. Let me explain it. Let me repeat myself so you can understand. All matters consist of many or small particles, so which are constantly moving or in continuous state of motion. So the degree, the degree by which the particle moves is determined by the size or the energy of the particle or the relationship of the particle to another particle. So that is the first state. You cannot, for example, let's say for instance, the rate by which I'm not getting into the kind of example that we best suit. So what we're trying, what am I explaining? Okay, let me just say you take a stone, a heavy stone and a small stone. Now, if you throw a heavy stone, the distance by which a heavy stone will reach will not up to the distance by which the stone that is small will reach. You know, the small stone, when you carry it, you can throw it because it's not much heavy. You can throw it and it will reach a long distance. But a heavy stone cannot reach a far distance. Why? Because of the size. Are you with me? Now, when I say that the relationship, the size can affect the movement of a particle, when we say that the relationship of the matter to another matter. So let me show you the example of that. Let's know that this is somebody, person A, and this person B. A is working faster. A is working faster, but B is working slowly. But B is working slowly. A is working faster, B is working slowly. Now, let me say on one way or the other, B tried to reach A, but now hold A. You know, when B hold A and want A and him to move at the same speed, now A is faster, but B is not faster. Definitely, the speed of B will affect A, or the speed of A will affect B. It's either B because of A and move faster, or A because of B and move slower. I'm still trying to explain the first kinetic theory of matter. So all matter consists of many or small particles which are constantly moving or in continuous state of motion. So, and we have give an illustration of example of that. So now the particles, those particles that are determined, those particles that are constantly moving or in continuous state of motion can be what? They can be atoms or molecules. Do not forget that your electron, your proton, and your neutron form what? Atoms. While your group of atoms give rise to molecules. While your group of molecules give rise to compounds. Understanding the class is the best goal of the class. If you have any question, drop me a message after the class. The particles that are constantly, which are constantly moving or in continuous state of motion, can be atoms or molecules. They can be atoms or molecules. Now, I think you've gotten that. Let's move into another kinetic theory of matter. Let's move into another kinetic theory of matter. Let's move to another kinetic theory of matter. So another theory of matter of a kinetic theory of matter say that so a change in phase may occur when the energy of particles is what? Changed. So a change in phase may occur. So when the energy of particles is changed. Now let's look into this. Let's look at an example of this. So a change in phase may occur when the energy of a particle is changed. If you carry a bike that is supposed to carry like 5 bags of rice. A bike that's supposed to carry 5 bags of rice, and you put 10 bags of rice on that same bike. So the phase or the reaction or the state of the bike will change. So the same thing applicable to when a bike that's supposed to carry 5 bags of rice, when 1 bag of rice is put on it. Significant changes in the what? In the bike. So what I'm trying to say in the essence is this: when the energy of a particle is changed, so it affects the phase of the what? Of the particle. When the energy of a particle is changed, it affects the phase of the particle. And this can be really explained under mass of a quantity. Now, if you put on a scale, a block on a scale, the scale will read some amount of it bring about the measurement of the block. When you add another block to the block that's already put on the scale, so it means that you are increasing the energy so that you are putting on the scale. Now, the change of space of a phase will occur. I think with that you could understand what I'm trying to explain. So when you put another block on top of it, so the energy will change, and this will affect the phase of the what? Of the particle. So that is another kinetic theory of matter. That is another kinetic theory of matter. So let's move to another one. Another one is that there are spaces. There are spaces between particles there are spaces between particles of matter. Just take it as it is. So there are spaces between every particles of the matter. Every particles of matter have spaces in between them. Every particles of matter have spaces in between them. And if I'm talking about the particles of matter now, remember what the particles of matter is. They are what? Atoms and what? Molecules. You understand? So there are spaces in between the particles of matter. Just take it as it is. Now, the last one that we treat now is there are attractive forces. There are attractive forces between atoms or molecules. Between atoms or molecules. And this becomes stronger, and this becomes stronger, and this becomes stronger as the particle move closer together. As the particles move closer together. Together. So you should know that in between the atoms or the molecules, there are attractive forces between them, and the forces become stronger as the particles move closer together. So they become stronger as the particles move closer. So the attractive force become more stronger. So that is the final part of the kinetic theory of matter that we discussed today. Now we can do a review of what we have been explaining so far, so that those who did not meet up can get the idea of what we have been explaining or talking about. Things. Now we start with the definition of physics as a branch of science that is concerned with the nature and properties of matter and energy. So we start with the definition of physics by saying physics as a branch of science that deals with the properties and nature of matter and energy. So I would say that the subject matter that we talk much about under physics include the what? The mechanics, heat, light. So the mechanics, the heat, the light. So and some other radiations. So radiation, we talk about radiation, we talk about the distance, the distance at which the distance at which a wave travels. Are you with me? So I am talking now, people can hear me. So my sound travel far. That's a form of radiation. So when you perceive a smell from a far distance, it's a form of radiation. The sound is heat. So that is radiation. Other radiation that we talk about. So under physics, we talk about sound, we talk about electricity, we talk about magnetism and structure of atoms. So and structure of atoms. So that is what we discuss about under the introduction to physics. So and we talk about the concept of matter. So we talk about the concept of matter, and we start with the definition of matter by defining matter as a substance, any substances that has inertia and occupy physical space. Something that has inertia and occupy physical space. So that is matter. So, and we say it consists of various types of particles, each with mass and sizes. So, and the most material particles of matter that we will be discussing about are, we talk about the electron, the proton, and the neutron. And the three of them come together, join is called atoms. So, we say that a group of atoms, that if you talk, when we talk about a group of atoms, we are talking about a group of the electron, proton, and neutron join together, form what? The molecules. And when you join different molecules together, they form what we call as compound. They form compound. So, and from there we talk about the state of matter. We talk about the state of matter, where we said we have three states of matter. We have the solid state of matter, the liquid state of matter, and the gaseous state of matter. So, we talk about the examples of the solid state of matter, which include, like example, the shock, book, so blood, and every other solid substance. So we talk about the liquid state of matter. Example, water, the liquor, so the petrol, and every other thing that we think about that they are liquid matter, liquid state of matter. And the last of it is the gaseous state of matter. So we made mention of hydrogen and oxygen as a typical example of gaseous state of matter. So I explained that different matters can come together, can join together to form another state of matter that is different from the original state of matter that are joined together. So we said a different matter can join together so and form another state of matter that are different from the original state of matter. So where I take hydrogen and oxygen. So as a typical example, when you add hydrogen and oxygen together, they form water. Do you forget that hydrogen is a gaseous state of matter and oxygen is a gaseous state of matter? But when these two matter are joined together, they give rise to another state of matter, which is what? Liquid state of matter, which is what? Water. And I told that the process of this is what we refer to as what? Chemical reaction. Chemical reaction. I'm trying to do the review of what we have explained so far. So, the process of combining different the state of matter to form another state of matter is what referred to as chemical reaction. So I think from there, that was when we tried to talk about the kinetic theory of matter, the kinetic theory of matter, where we say that all matter consists of many or very small particles, which are constantly or in continuous.
Good evening, all. Good evening, all. Thank you once again for joining us. We appreciate